Hi, good morning. Hi, thank you so much for having me. If you've seen me lecture before, you've seen me lecture with a gentleman named Augie. He's not here this morning because it's his son's first birthday. He wanted to be at home for that. It's my 37th birthday, and I'm spending it with you, and I'm really happy to be spending it with you. So, thank you for having me. And we're going to start the lecture today by jumping right into some code. All right. This is some code. I wanted you to see the top of it. Yay. This is some code. This is one class. I hope you all can read. Can you see in the back? This is one class. This is not made up. This is not imaginary. This is a real class in a real code base that you have probably used. It is 1,700 lines. It is 74 public methods and 36 private methods, and 18 public attributes and 9 private attributes. And it's not a problem at all. This is totally okay, because today we have big computers with lots of memory and powerful processors, and it doesn't choke the compiler, it doesn't choke the interpreter, it doesn't choke static analysis tools, it doesn't trip up our super powerful modern computers, and it's not a problem for the users who use the software because they don't see the text of the code. They only see the behavior that the code generates in the machine that they're holding, right? So it's fine. It's a beautiful day out, end of the lecture, we can go. Not quite. It turns out software is made of people. Most software is developed collaboratively, and so a long class like this is probably a problem for actual engineers. The guilty class here is local repo.local repository in Mercurial. It's public. You can go look at it today. We chose it because the authors know that it's a problem. Specifically, the code is lacking what we call readability, which is kind of it means what it sounds like it means. The property of the code being able to be understood by someone reading it. And readability is what your code needs because you don't scale. On a successful software project, you may have hundreds of developer collaborators, and you may have tens of thousands of developer users writing their own code that calls your code. You're not in a position to go and explain to them how your code works and why you made the decisions that you made and why it's shaped the way it is to all those people. Your code needs to describe itself to them as you would describe it to them. You also don't scale in time. You may know how your code works today, but 12 months from now, after you've been doing other things and you get a bug report and you have to come back to your code needs to describe itself to you the way you would have described it at the time that you wrote it. Now, in the hierarchy of software needs, readability is not the first thing that code needs to have. Code needs to be correct. First and foremost, before anything else, that's code's first priority, is to deliver some useful value to some user somewhere, provide some benefit, and also to do no harm. The second thing it needs to be is reasonably efficient. It needs to complete in a reasonable running time. It needs to only use the memory that's available to it rather than every atom in the universe. Readability is at best your code's third priority, but it's independent of correctness and efficiency, so you have no excuse not to do it. In that big class that I just showed you, my first complaint with it is a lack of cohesion. It's a grab bag. It's got too little relationships among its parts. If I were to show you at a reasonable speed that you could read, if I were to show you the text of just the first half of the class, I don't think that you'd be able to guess or have any idea what was in the second half of the class. There's no big idea that the class is about with everything in the class working toward that. Instead, it's just a mishmash. It's storage logic, it's business logic on top of that storage, and it's a data container for related data and some unrelated data. There's a field on the class which is publicly visible and not used anywhere inside the class at all. It's for other things to kind of store into and read out of. I found that really strange. we think the class could be at least 3 different classes at 3 different layers of abstraction. Another complaint with local repository, it mixes function and convenience. It's great for a piece of software to be both functional and convenient. We think that's the whole point, but it's a little too much for one class. We think it's better if there's one class that implements functional business logic and complex behavior, and there's some other class that uses that first class to provide the convenience, to provide the sugar, to translate into terms from the problem domain to the terms that the user might want to see exposed directly to them. In this method, it has the decency to come out and say, this is just a convenience method. But look at it. It could just as easily be a helper convenience function outside the class. It's only using the class's public API anyway. Local repository mixes layers of abstraction. And that's difficult for readers because when a reader encounters something like a method, they may not know whether the method's going to be implemented at a high layer of abstraction within the class or whether it's going to drill down to one of the lower layers of abstraction in the class. There are just too many elements in its API. Most people have a working memory of 10 items. 92 is just too many. It's hard to pick out exactly what the right size of an API should be, but we think it's a bad sign when you're using the language of segmentation and subdivision in stating your API. We think that suggests that it's too large. The text of that class is just too long. It's 1,700 lines. We think that's like a magazine article or a blog post. You shouldn't sit down and get a cup of coffee just to read a single class. A class should be shorter than a cup of coffee. Now, code length, we hear it talked about in a lot of bad ways. I sort of want to dig into the reason that I think code length is a problem. And so let's look at a sample long function. This is kind of a generic function. It takes a parameter, it computes several intermediate values, all based on everything that was computed before, and then it returns some result. And the first thing you notice is there's a quadratic number of connections that as the body of the method goes on, there's a quadratic number of references of things being used in computation of new results. The reader of this function also has to remember the values, the names, the local scope of everything that's been computed so far. So that's a burden on readability, that's a burden on the reader's memory. It's also not realistic. Most long functions are actually more like this, where there may be a large number of results computed, but each intermediate result depends on the 2 or 3 or 5 or 6 results that came right before. So you might think like, okay, this is more realistic. It's not a problem for readers then, because as they learn new bindings in the scope, as they read the text of a long function, well, they're able to relieve themselves of the earlier things that aren't going to be used anymore. But that's not true. If you actually imagine yourself in the moment about to read the next line of this code, maybe the next thing to be computed only depends on the last 4 or 5 things to be computed, but it could depend on everything that's available in the local scope. So when you're reading this, you have to keep everything that's been computed in the local scope in your mind. That's a tax, that's a burden, and just also imagine what happens when you pass the return statement and exit the function. Your mind gets to think of the function just in terms of its parameters, its return value. You get to clear your head, you get to move on to the next code element with more memory available to you. That's what makes long code objectionable, at least to me. Local repository was not inflicted by a malevolent enemy. Nobody sat down and said, today I'm going to write a 1,700 line class. It accumulated, it aggregated from well-meaning changes, and those changes only had to satisfy 2 requirements. They had to meet some need, they had to deliver some user benefit, and the author had to understand them, not anybody else. All it took was the author to understand. And so to make code understandable to others, it's an add-on. It's something extra. It's something that is not innately part of delivering correct software. And so it's something you have to argue for. And most of the time that you're arguing for it, you find yourself talking in terms of, well, how much should we invest in this code because how long is it going to last anyway? And most of the time we guess about the lifetime of our code, we guess short. We think, oh, this is a prototype, we're going to throw it away when we implement the real thing. And 6 months later, people are paying for it, and we can't drop support for it. So if we want to improve readability of code, we can't stop the world and refactor everything. We need tools and techniques and practices that we can adopt that improve code on a going forward basis. So we're looking for something like silver bullets or fairy dust or pixie dust, something that avoids us having to say, we're going to invest a lot now and you'll be so happy in 10 years. Something we can do on an incremental basis. And to start that, I want to pull up this famous quotation, one of my favorite quotes from one of my favorite books. How many of you have read this book? Remember this quote? Most of the time we bring up this quote, it's talking about the relative value of learning a system from studying its behaviors or studying its data structures. And it's saying you should study data structures. And I agree with that, but that's not why I bring it up now. I bring it up because he's saying he can understand the code without understanding the problem domain, that all he needs is the code. So readability and understandability of software comes from the software itself, not from the problem domain. That's good news, because we can't generically make problems easier. I can't make AI easier. I can't make games easier. I can't make vision easier. I can't make networking easier. But if readability of a piece of software has little to do with the problem domain, that's good. We can always change the software. In particular, the two biggest obstacles to readability tend to be how program control is passed from one part of the code to another, and where the state is changed. So things that obscure program control, like concurrency, make a program harder to read. Things that obscure state changes, like mutable objects that change between when a function passes them to some subordinate function and gets back the result of that function, that makes code harder to read. Mutable global state is always present as a kind of background effect, that it can always interfere with the operation of a function that looks like it has nothing to do with anything except its parameters. In particular, mutable global state kind of reminds us of why do we perform physical experiments in laboratories, in the real world, in the physical world. We perform experiments in laboratories because we want to screen out undesirable influences, screen out background effects. And similar, why do we build delicate or complicated or delicate things, or unstable things? Why do we build them in clean rooms? We want to prevent contaminants from interfering with the yield and screwing up our and interfering with our manufacturing process. So there's a physical principle there that says, do where the doing is simplest. Even if it's an artificially constructed vacuum chamber that screens out everything it possibly can. That's artificial, sure, but that's great. That's how you get good yield. That's how you get a reliable, reproducible process. We can take that principle into software and say, code where the coding is simplest. If there's a circumstance where coding is complex, try not to code there. This is a pretty good principle. Let's try to put it into practice. Here's a class. It's a pretty short class. Maybe it's part of a larger code base. It's definitely part of a larger code base because this class has a superclass that we haven't yet read. But let's imagine that you're maintaining this code and you want to answer the question of, can the value of this constant be changed? Or can the constant be renamed? Or can the constant be removed? What do you have to know? What are some questions that you would have to ask? Right here in the yellow. Right. We need to look at the foo class, and what do we need to look for in the foo class? Is the value used or possibly defined there? How is the value used there? What else? Look at the subclasses. Is the value overridden in subclasses? Is the value used in subclasses? Anything else? Look for monkey patching. Okay, so we need to look for all of that. We also need to look, is the constant shadowed by any instance fields? Instances either of this class or of subclasses. And since the constant is public, we need to ask, is it used anywhere? These are all questions that we need to answer before we can decide, do we change this value? Do we remove this value? So placing a code element at class scope invites all these questions, questions that your code's maintainers are going to have. And your maintainers are going to need to know the answers of all those questions. Code where the coding is simplest, avoid placing code elements at class scope unless you absolutely have to. You have no alternative. We tell this to people. They seem pretty persuaded by it. They seem like it's a good idea. And then they come back to us with code that has code elements at class scope. And they tell us, well, the class looks nice with it there. Or I really feel like I want it there. Or the most concrete thing they say is, well, it's only ever used from the class, so it feels like it should be in the class. And we love this last one because it's so easy to contradict. That if you're someone who believes that is only ever used from implies should be syntactically nested inside, just go write your program as one giant main method, top to bottom. Because every code element is used either directly or transitively from your main method. So if you believe that is only ever used from implies should be syntactically nested inside, do that. It's easy to see why that's a bad idea, a poor idea. And if something is only ever used from a class, that's not reason to put it in the class. In particular, an absolute requirement is the class cannot function as required by its users without the code element at class scope. So if code elements don't go at class scope, they go at module scope. Place everything at module scope by default when you're writing code. When you're writing new code, when you're maintaining existing code, place any additional code elements at module scope. Only promote them into classes when you're absolutely required to do so. Classes go at module scope. Functions go best at module scope. Constants go best at module scope. If you have some test data and it's only ever used inside one test method, you can leave it in the test method because there's some value in locality. I'm not a big fan of locality, but you don't have to take that out of the one test method where it's used. So even if you squeeze everything out of your classes that you can possibly squeeze out of them, you're probably still going to need classes to accomplish useful things in your code. We're not going so far back in time in programming that I would want you to program without classes. But do be a class realist. Only use classes for what classes are for. And what are classes for? 4 reasons, 4 legitimate uses of classes. The first is that classes provide a way to structure and aggregate data. This would be like a struct or a named tuple. The important thing here is that there's no behavior. There are no methods, nothing interesting happens inside the constructor. This is just a data container class. It aggregates and it provides a type for some other data. The second legitimate use of classes is to define a type. If you're implementing some system and your system is partially abstract and you need to tell the users of your system that to get the full features of your system, they need to provide an object, a plugin of some sort that implements a certain behavior, you're going to specify that behavior to your users using a class. You're going to tell them, implement this class and pass your implementation to my system. The third legitimate use of a class is to implement a type. If somebody's done what I just described to you and you want to use that system, they've provided a type, you're going to use a class to implement that type. And the fourth legitimate use of a class is, this is a lot of words, but it's just a technical way of saying the kind of thing that you learned what classes were for when you were first learning about classes. You can create arbitrarily many instances of objects that are the same in some ways, and those some ways correspond to their methods, and different in other ways, and those differences correspond to different values of the instance fields of that class. So if you have a square, they might have different side lengths and different colors, but they're all squares. And in particular, so for legitimate uses of classes, don't mix them, except for the last two. If you're tempted to have a class that's partially abstract and has some abstract methods and some concrete methods and some state, that's always better as two classes, one purely abstract and the other purely concrete. If you have a class that is trying to combine the first and the fourth so that it contains both methods and public data, that's probably better off as two classes, because the methods almost invariably will use the data, and that'll put your class kind of at two layers of abstraction. That's better as two classes as well. Some other things classes are not for that we see kind of commonly is being functions. You might think classes and functions are so radically different. How could anyone possibly be confused? I mean, they're both keywords in the language, and they're used in such different ways. This is an example, these first two lines at the top, this is an example of what we call a class that wants to be a function, where not only is this the only way that the class is used, but it's the only possible use of the class. It has one public method, and that method returns some other value, and there's nothing interesting about the class. So all the uses of the class look like this. And that object, the my object there, nothing of interest is done with that after these two lines. It's just allowed to be collected. This is a class that wants to be a function. And if you step through this transformation, you can see it boils down to putting the statements that are executed in the constructor, badoink, next to the statements that are executed in the one single method, badoink, together into one common function, and just eliding the class. We see this a lot. I think it comes from people not realizing that they have a function. They think they want to use their function local state. They think they need an object to wrap it up. Classes that are concrete but never instantiated are another kind of warning sign. They're usually, when we see them, they're grab bags or they're namespaces. Python already has namespaces. Modules are Python's mechanism for namespaces. So use a module instead. We see classes misused for what I'm going to call enumerated polymorphism. This is kind of like polymorphism where you define a type, but instead of there being arbitrarily many implementations or user-provided implementations, what you have instead is a situation where you think you know what the 3 or 4 or 5 specific implementations of this class that are ever going to need to be will be. And so when we see this, we see authors define a superclass like this with perhaps some concrete and perhaps some abstract class scope elements. And then we see them define the few specific implementations of that type also using class objects. Don't abuse class objects this way. It's kind of misleading. It's not the way readers expect to see polymorphic relationships represented. Just go ahead and use instances in the ABC module. Another misuse of classes has to do with science fiction. So depending on the lighting in the room, you may or may not see a comment there. How many of you have ever seen the science fiction movie where something alien falls to Earth and some scientist goes and discovers it, and it's really powerful alien cool stuff, and the scientist drags it back to the laboratory and tries to work with it and tries to use it for good, but the alien thing takes over and the scientist becomes the villain and has to be defeated. And at the end of the movie, the scientist says, "I tried to use it, but I ended up becoming it." Have all seen that movie? Okay, good. That's what mixins are. Mixins are classes that ostensibly want to help your class, but the mechanism by which they offer their help to your class is inheritance. So your class cannot use a mixin without becoming a mixin. Remember that if you're writing a public class, your class's superclasses are part of the public API of that class. So if you inherit from a mixin in a class that you don't want just to help, that mixin is going to be part of your public API. It's probably going to add some API methods that you hadn't necessarily wanted to include in your class. Don't accept mixin's help. You don't want that kind of help. Your class doesn't benefit from that kind of help. So classes have some legitimate uses, some illegitimate uses. There's just a couple more things to say about readable classes and their design. Avoid self-use of your public APIs if you can. There's kind of a carve-out here for, unless it's a deliberate, intentional part of your API that you loudly advertise to your users. Avoid poorly reasoned self-use of your public APIs. Your public API should really be at one layer of abstraction. And if one part of your public API makes use of another part of your public API, it invites the question of, are there two layers of abstraction here? Why is this one part allowed to use this other part? Would it be legitimate for the second part to use the first part? And you got circular reasoning there, you got abstraction violations, and you could operationally get infinite recursion, but I'm thinking more semantically. Avoid self-use of your public APIs. It also interferes with inheritance if you've read the very excellent portion of Effective Java that deals with this. Avoid self-escape in your instance methods. Don't pass the self-reference out to some other system. This is kind of similar. It invites another question about abstraction, where in healthy code, in readable code, your calls should all be going down layers of abstraction. But if you pass your self-reference to something else, that something else has the full power to call the entire public API of your object instance. And it invites the question of, well, which object, either your instance or the other system, is at the higher layer of abstraction? It's also almost always not what you really intend. Just ask yourself, do you really want that other system to call any arbitrary method in my object's public API? The answer is almost always no, and it points to what subset of your object instance you want to pass to that other system instead. It could be the value of an instance field, it could be a few values from the instance, it could be a bound method. It's going to be something less than the entire object instance itself. Minimize your instance state. I've seen this in code where there are fields on an instance that say this field only has values during calls to my method 2, my method 3, and this field is not legitimate otherwise. That invites the garbage collector to not be able to find your garbage. Don't do that. It also makes your instances harder to understand because your readers should be able to count on every field within your instance having some meaningful value at every part of your object's life cycle, even if it's only, this is not set yet. There should be meaning to every field in your instance, even when no methods are being called on your instance. And that's everything about classes. We have just a few things to say about modules. Always place your imports at the top of your modules. Circularity and cyclic references among classes and among functions, they have their place, but healthy code tends to have a directed acyclic graph of modules. You can enforce that by just having all your imports at the top of your modules. We think you should import modules referenced in specification. So even if the interpreter doesn't require you to import a module, just because you have a function that either accepts a parameter of a certain type or returns a value of a certain type, we think your code has a semantic dependency on the module in which that other type is defined. You should reinforce that semantic dependency by having the import in your code saying, logically, my module depends on this other module. My module doesn't make sense if this other module cannot be found or doesn't exist or has changed in some critical way. Default to using private visibility. Only promote code elements to public visibility when you've really decided that you want to. I I don't know what it is. To some people, the underscore looks unattractive, or maybe it's that underscores are rarely used in sample code to illustrate making everything private by default. It's a really valuable principle. The underscore only looks unattractive the first 600 times. Those are all pretty easy rules. I hope they go over well. I hope they provide value to you. We're going to go over a few more things, and these have more to do with resigning your judgment, setting your judgment aside, and in particular, setting your judgment aside at one time, or making plans in one moment, knowing that your judgment will be compromised in some later moment. So this is Odysseus with the sirens. His judgment is compromised, but it's totally cool because before, when his judgment wasn't compromised, he said, tie me up, don't listen to me later on when my judgment is compromised. Let's take this back into software with the situation of you've been working on a really hard problem all week. You've been working on it at your terminal, at your desk. You've been thinking about it when eating. You've been thinking about it when bathing. You've been thinking about it when falling asleep and when waking up. And you've got a solution. That's great. You've implemented it. You've debugged it, you've tested it, you've delivered it to your users are happy, you've provided value, you've really done a fantastic job, that's great, but in that moment of having just solved that problem, after having worked on it nonstop, are you really in a position to decide what's obvious and what's obscure and what's self-evident versus what needs to be commented? Probably not. And don't you wish you had signed up for something to sort of keep yourself within reason about how the problem works and how your solution works? That's where metrics and limits on metrics for your code come in. A lot of people say, like, I just can't sign up for metrics. I think I'm always in a good mindset to know exactly how long a function should be, and if a function feels too long, well, I have a good reason for it. But they all seem to know what a reasonable limit on someone else's code should be. How many of you have ever asked why a function is too long and the author has told you this? Did it win your respect? You don't want to hear this from other programmers. You don't want to say this to other programmers. You probably want to keep your functions and your code elements and your classes within reasonable length. Sometimes it's hard, especially after we've just solved a problem, especially after we've just been wrestling with it for this whole time. And why is it hard? Well, because our function probably looks like this. It takes an A, B, and a C, and it returns to its users an X, Y, and a Z. And that's what the problem is about. The users have an A, B, and C. They want an X, Y, and Z. We've implemented our function in terms of A, B, C, X, Y, and Z. So 400 lines or 500 lines or however long it took, that's kind of the fundamental essence of the problem, right? And what we're having there is, what I have in this situation, is a reluctance to introduce intermediate concepts. A reluctance to say, actually the problem is also about some D through W, D, E, F, all the way to U, V, W. And those may be private. They don't need to be exposed to the users. They can be private helper methods, private data structures, and some of them may be just a few lines of helper function, a very short name tuple helper data structure for intermediate results. Go ahead and introduce those intermediate concepts, even if they're too obvious. It's better to be too obvious when coding onto others than not obvious enough. Don't abbreviate when naming. You get to use existing abbreviations like TCP, HTTP, SQL, but don't create new abbreviations. Software is just getting more and more and more cosmopolitan every day. I'm at a conference where I'm not going to understand a lot of the content. You may be working on a code base where the person maintaining that code a year from now doesn't speak the same language as you, or they don't speak the same language with which the code was authored and with which the documentation is authored. Spend a little horizontal space to give those maintainers something they can look up in a dictionary or a technical glossary. In storytelling, there's this convention of always describing a personality or a character in isolation before showing them interacting with the environment or with other characters. So if you go out to a play, you may get a playbill, like a cast of characters like this. If you watch a sitcom, you may see a title sequence that explains who all the characters are and how they got where they are. If you play a video game, you may see an intro sequence. This happens in journalism, and it's so strong a convention that when it doesn't happen, it's a narrative technique to jar and surprise and put the reader ill at ease. When a character kind of comes out of nowhere and surprises other characters that the reader or viewer knows. This also applies in software as you're reading code. So we might read this code, and there's a function, and we see that function defined, and we get to know it. And we see a second function defined, and we get to know that too. And then we see a third function, and in the body of that third function, it uses the first function, which we know. This uses the second function, which we know. And then it uses some code element we haven't seen before. And if we want to understand how this function works, we need to pause our reading right here and scroll ahead to wherever that other function is defined and understand it there, and then jump all the way back and kind of restore state, kind of pop the stack frame in our mental comprehension and complete our understanding of this function. You can avoid asking your readers to do that by just sorting your code elements in definition before use order. The only thing that can stop this is if you have mutual recursion. Mutual recursion has its place, but most of us don't use it every day. If you do sort your code in definition before use order, you see you can read this code from top to bottom. Your readers will be able to read this code from top to bottom and not encounter any surprises, not encounter any terms being used that they haven't earlier seen defined. I like this, I advocate it, and sometimes I get pushback. Sometimes people say, I really want the public parts of my code to be at the top of my file so my users don't have to scroll. I like getting that because it has another easy response to it. The easy response is, your code has two audiences, maintainers and users. You can please all of the people some of the time, but this is not one of those times. You're going to have to choose between your maintainers and your users for this. Favor your maintainers. Your maintainers have to read your code. If they want to fix a bug, if they want to implement a performance improvement, they're going to be right there in your code. Your users can be directed to your documentation. Generated documentation, hand-authored documentation. Your users don't actually have to read your code. This can be surprising to some people, especially people that have been long in the open source community, but users don't actually have to read code to use it. It's fine to read documentation, it's fine to read specification. So favor your maintainers. Readability is good for your code. It's a priority. It's independent of correctness, efficiency, and problem domain. Classes invite questions and complexity. Be afraid of classes. Don't stop using them, but be respectful of their power. Minimize the code elements that you place inside them. Only use classes for legitimate purposes. Consider setting some of your own judgment aside, signing up for metrics, saying, I'm not going to write a class longer than 200 lines. I'm not going to write a function longer than 30 lines. Try it, see what's right for you. Maybe the numbers will be different. And when you're forced to choose between writing your code to meet the needs of your code's future maintainers or the needs of your code's users, favor your maintainers. Thank you very much.
У нас есть время для вопросов, если у кого-то есть вопросы.
When people are writers who write, for example, science fiction or articles, they are trained two times. First, they learn how to use language in university, and then they are they learn how to use language in order to express themselves in a special journalist course. Yes, for software developers, as I can see right now, most of educations teach people how to use programming language syntax. But I doesn't see any good amount of education material that teach people how to use language in order to correctly express themselves, so their colleagues, other software developers can read the resulting code. What do you think about education, and do we need some additional education that will teach software developers the things you just told us about?
Thank you. I agree. Yes, I do agree that education has a place. And I don't yet know the mechanism. So I work in Google, I work in an organization within Google called Readability. And right now it's kind of a tribal effort. It's kind of a person-to-person effort that's not scaling very well. Teaching a lot of these techniques. I give these lectures, and I agree with you that there's room for formalism. Whether it's narrowing what languages allow, because a lot of the guidance that's given in this process is to say, well, just because the language lets you do something, that doesn't make it a good idea. I don't know that narrowing what languages allow is a good thing, is the right solution. Tools like lint checkers, I'm a big fan of lint checkers. Those help. But the short answer is yes, I support this education, and no, I don't know the mechanism for it. It may be per language, and it tends to follow, from what I think I've seen happen, it tends to follow 15 to 25 years behind the language itself. So people figure out what really are the best practices long after a language has been designed and implemented. And that gap, that delay, may be part of the challenge. Thank you. Okay.
So, question. Do you also have size limitations on modules? Because a lot of the advice you give seems to be designed to do exactly to modules what you told us not to do with functions, by increasing the amount of things that are in scope at the module level. So you've got the same quadratic problem one level up, and how do you solve that? And do you then just impose module size limits, or is there something else you do?
The question, for those who didn't hear it, is do we impose module size limits? Because it looks like if we have limits on smaller code elements within modules, things get squeezed out to module scope. And in practice, what I've found in my own code is I can generally meet module length targets by using techniques like not having a limit on the number of modules in a package, having package private helper modules, and pushing the problem to the next layer of abstraction. That is not a satisfactory answer in theory. It's a surprisingly satisfactory answer in practice. I just have yet to write a system that's so big that I have too many modules, too many packages, and even things like package private helper subpackages don't meet the scale. Maybe if I met a code base really, really large, I would reach the kind of scaling limits. But for now, for the kinds of code that I think are common, that I think exist in the real world, I think the scaling limit isn't quite met, and it's definitely worth it to pull things out of classes. Whether things get moved from one big module to another smaller module, it doesn't affect things as much as pulling things from a large class out into module scope.
Thanks for an interesting talk. What do you think of synthetic sugar? Well, sometimes you want to to make some object act, well, just more convenient for user. Just as example, it's easy to make a decorator with a function. It's easy to make a context manager with a function, but it's really not easy to make just an object that acts as a decorator and a context manager with a function. It's easier to use a class.
Okay.
And when just a coder needs to stop and when it's better to not to invent a more convenient syntax sugar.
I'm going to take the long way around to the answer to that. And what I'm going to say is that in my public APIs, I try to be as minimal as possible about what I'm promising to deliver. And so that means that abstract classes and type definitions, purely abstract classes, have a big part in my public API. And so I'm able to define those for users in terms that I think will make users happy without any concern about their implementation at all. And that means that when it comes time later on to actually implement my APIs, I can have one object that does all the complicated logic, and I can have a second object that is a delegate. No, the first object is a delegate of the second object, and the second object is what actually implements the type that I've defined for my users. So I love syntactic sugar. I love delivering solutions in the terms that users want them delivered and that users find helpful. And what allows me to do that is that I have so few concrete classes in my APIs that by only promising some implementation of some abstract type to my users, that gives me the freedom to implement inside my system, in the private implementation of my system, to implement what the user sees as one object. Could be 5 objects to me, it could be 10, it could be 2. It's rarely 1.